Hello, Flat Earth researchers, debaters and debunkers. Right, following my 2 expeditions to see what happens at the vanishing point, or the convergence point, the horizon, when we're at ground level, I've come to a few conclusions, or observations at least, opinions about what's happening at the convergence point, or the horizon that we see. So I've done a little diagram to try and explain in 2D what we're seeing in 3D. Okay, so this isn't conclusive proof of anything else apart from observations as to what happens to our line of sight, to the horizon, to the convergence point, when we raise or lower our point of perspective. So lowering right down to the ground is where you get this obvious shift, and you can see what's going on a bit more. So what I found is, after 2 experiments on straight roads, as straight and level as I could find at the time, we get the same effect of cars, people appearing to disappear down a curve into the distance. But both those places there was not an actual curve in the road. Now, I can see what's happening with some people is they are, you know what happens when a car goes over a hill or something. You see that every day. So of course, when we see things going off into the distance and disappearing from the bottom up, we think the same thing's happening from what we've seen and experienced, which is genuine. You know, when we see a hill, we see things go over a hill, they dip down. But you've got to remember too, when they do hit that curve, when they do go down over a hill, they angle down. They do angle down. So this thing about, if buildings are beyond the horizon, they should be angling away from us. Well, that's entirely true, because you think about it. If you watch a vehicle go down a hill away from you, then you do see it angle. You see, the back end of it comes up, and you see more of the bottom as it disappears down the hill. But what we're seeing at the vanishing point, or the convergence point, is vehicles disappearing from the bottom up. And then they go through this point, this kind of area, right here in the middle here, the vanishing point, or the convergence point, or the horizon. So, okay, now when I say horizon now, I'm not automatically assuming that we include the curvature of the Earth as the horizon. If there is a curve, these are 2 separate things, and that's what I've been trying to do for the last 2-3 months, is observe how many different things are going on here when we look at objects disappearing into the distance. You can't just say it's curvature. There's so many variables, and of course one of those variables is what we actually see. So it appears to me that we have our line of sight. Okay, this is not to scale, please note. Okay, so we have our line of sight on a landscape. Okay, I'm just making it flat just to illustrate the point of the vision. Okay, what we see regardless of any shape or form of the Earth. So, and from at some point in ahead of us, what we see, the ground we see and the sky we see, starts to come together into a convergence point. We know this when we talk about the parallel lines of a road or a railway track. we know we see that, but we know they don't ever come together. So we know this is an accepted visual phenomenon, an optical illusion, as it were. Okay? That happens, regardless of the shape of the earth. So this is what I see happening to our vision. So we've got this car here that, as it goes past the point where light starts to bend up towards the convergence point, then that's where it starts cutting off the bottom of the car. Yeah, you see, light bends view of landscape to the convergence point, so it starts bending the light here and takes it up to here. So whatever we see along this line ends up kind of angling up to the vanishing point, even though whether it's on a flat or a curved plane, it's there. So we get this point where the car has completely disappeared, pretty much. You know, you get really down low, and everything just gets refracted, I suppose. Everything just gets boom, bent out of shape. So essentially, its form disappears from what we normally see. But then we come along, and it appears to me, and this is observations on what I've seen. Okay, it appears to me that after this vanishing point, things pop out the other side. If you've got a clear enough view, if the road is straight enough, okay, and the objects are big enough as they get further away to come back into this line of sight here. So where it's come to the horizon point, the convergence point here, it now comes back out again. So there's all this ground down here. All this ground down here, and this space we can't see. Again, this point is going to be depending on our height. So obviously we bring it down to the ground, or we can rise it up, and everything, all the angles change. But so then, you know, the line of sight expands again beyond that. So okay, you know, smaller objects we're not going to see, they're just going to be too far away, or just not reflecting enough light to kind of pass back through this. So this is like a, you know, a black hole, as it were, where it's a point where light doesn't come back. You can't see the light reflected from things going on here unless it's being brought in from here. Yeah? Okay. So then we get this band here that's kind of from the vanishing point, which goes out towards the horizon, where we can't see anything. Hence, we see no stars on the horizon. But we might still see objects and the land and the geography that's continuing on into the distance. And of course, up there we can start to see the stars above and the moon above the horizon as our view expands again. So of course you look up, and you know, you get that section of sky that you can look at. You can never see the whole thing looking directly ahead. And that's something I thought about with the laser beams as well, where in Jeronism's experiment, when he shined up the laser into the sky, I've done the same myself, and yeah, there's a point where the laser just stops. The light of the laser stops. So maybe that's the optical vanishing point. That's as far as it's going to go. That's as far as we see it go. And then, boom, it meets that vanishing point way up in the sky. So anyway, here's the kind of conclusion. What we have is light bends the view of the landscape to the convergence point. So the lower the viewpoint, the sharper the angle and shorter distance to the convergence point. Okay? You go down low, and you bring the convergence point closer to you, and there's a sharper angle to it. So that's why when you lower the camera, even though there isn't a bend or a dip or a bulge in the road, it suddenly appears that there is, because the light is bending more sharply up to the convergence point from your low perspective. Yeah? So you go down low, the vanishing point comes closer and higher. Okay. Alright, so lowering the viewpoint equals a sharper angle and a shorter distance to the convergence point. Okay. So the observation here is that light is bending our view of the landscape to the horizon. Okay. We see an optical illusion. We do not see the true shape of the landscape. Okay? Alright? What we're seeing is an optical illusion, not the shape of the landscape when objects disappear in the distance. Thank you.